Chapter 3, Video 2, The Biosphere. A population is a group of organisms of the same species living under the same area. All populations undergo three distinct phases during their existence: growth, stability, and decline. Initially, a population will sometimes undergo exponential growth until it exceeds the capacity of the environment to support it, causing what we call overshoot. Here is the exponential growth, and here is the overshoot portion of the curve. Notice stability is at a lower level than overshoot. Each population grows at an intrinsic growth rate, labeled R, that is determined by many factors, but is primarily the birth rate minus the death rate. Each age structure also affects the growth rate, which we talked about in Chapter 2. When we talk about population stability, population growth is eventually limited by a complex interaction of many factors, including other species. Carrying capacity is the maximum population that can be sustained by an environment for a long time. Factors that limit the rates of reproduction and survival occur in both the physical and biological environment. Physical limitations include things like competition, symbiosis, and predation. Habitat determines physical constraints. A law of the minimum is defined as population being limited by the resource in shortest supply. Competition, which can lead to competitive exclusion, occurs when there is minor niche overlap that can limit abundance of both species. When niche overlap is higher, it can exclude the less efficient species, and you get competitive exclusion. Let me say that again. When species niche, or where they exist in their habitat and their ecosystem, overlaps, minor overlap can limit abundance of both. When you have major overlap, where both environments are overlapping a lot or completely, one species might be excluded if it's less efficient. This results in competitive exclusion. Symbiosis is a general term meaning live together or with. It encompasses different relationships between unlike organisms that are classified based on their benefit or detriment to each other. In symbiotic relations called mutualism, both organisms benefit. In symbiotic relations called commensalism, only one of them benefits. And parasitism is where one is harmed and the other is benefiting. When you talk about amensalism, we're talking about parasitism at the community level. Most natural populations are governed by several controls, often acting simultaneously. The addition of a third species, say a parasite, changes the success of two competing beetle populations, shown below. Natural communities are composed of populations of hundreds or thousands of species, so interactions can be very complex. In the graph on the left, we have two beetles growing in an environment that overlaps, where niche overlap occurs, and one beetle is more efficient than the other, and so that it's doing quite well, while the other beetle is basically undergone competitive exclusion. When you introduce a parasite to beetle number 1 into the community, the population of beetle number 1 is brought down very low within the community, and the second beetle can thrive. This is still a very simple relationship, and if you try to think about how many types of organisms might live in in an environmental community, you can see where impacts might be great. One of the biggest populations to impact others is us. People can cause population growth by removing previous limitations in an environment or ecosystem, or population decline by imposing new limitations. People cause population increases by providing an increase in available resources, by providing competitive release, predator release, and introduction of species into new areas. People cause population decreases through habitat disruption, introduction of new species, overkill, and secondary extinctions. An example here of species introduction shows how the impact can be large or small. The introduction of non-native or exotic species like the European starling may be the single greatest alteration of nature people have carried out yet. When starlings were introduced some 150 years ago, or 250 years ago, you can see that they spread throughout the continent and were very, very effective. The habitat disruption caused by starlings was great, and to this day, the impacts are still trying to be measured. Once the organism gets established, population and range expansion can be quite rapid. Recent examples affecting Maine are the northern pike, many plants and other species found at this link here. As he tries to click on it, it won't work. So if you look here at the Maine invasive species page, I can't capture it all. You can then go look up what species are affecting Maine from what other areas. For example, if we go on the insects and marine fish page, we can see that the European fire ant, the gypsy moth, spotted wing Dropsilia, and then other pests like the emerald ash borer, which is new, and the longhorn beetle hemlock woolly agilid, which is also new, are invading our state. This is true also for marine species, the most talked about one being the green crab now, and this doesn't even talk about, and the northern pike, and this list doesn't even include the plants that are now considered invasive species in Maine. Populations tend to have maximum abundance near the center of their geographical range, which is the total area occupied by the population. The maximum occurs where the physical and the biological factors that control abundance are most favorable. Optimum range, greatest abundance. Less optimum, lower abundance. Let's review what we talked about in these 10 slides. We should know what the physical type, the typical phase of a population will pass through over time. What are the basic abundance controls in place? And how have people influenced and affected the size of population? Can you think of a mutualistic relationship between the human body and other organisms?